Okay, today we're going to continue on with exponential functions. We're going to solve some problems and basically just see how this works. Okay, so let's talk about exponential functions, and we have a is greater than 0 and a is not equal to 1. This is the definition of an exponential function with base a, and it's given as f of x equals a to the x. So this is the form or the expression that we give for an exponential function. Okay? So again, why? Okay, so we have these restrictions. We'll talk about those restrictions now. So the reason why we have a has to be positive and a cannot be equal to 1 is for two reasons. If a is negative, well, in that case, for example, if we use -2, so y equals -2 to the x, well, if x is 1/2, right? If we put in 1/2 here, well, that means that I'm taking the square root of -2, which is not a real number, okay? So again, this has to hold for all values of x, okay, in the domain, okay? So this has to hold, okay? So it doesn't hold for x equals 1/2, so we can't have a and b negative, so it has to be positive. Okay, the other reason is, for the other restriction, a is not equal to 1, is because if a is 1, then we don't have an exponential function anymore. Because if we write y equals 1 to the x, that's just a constant function, right? It's just it's the same as just having a horizontal line, okay, at y equals 1. So for that reason, for those two reasons, we have those two restrictions. Okay. Okay, so now let's do an example. Let's do some examples. So we're going to use f of x equals to 2 to the x power. Okay, so there's our exponential function. We're just going to evaluate this function. So f of -1 means that wherever x is, we're going to substitute in -1. So we're going to write 2 to the -1 power, which is the same as what? Again, we're going to use the rule of exponents, or properties of exponents. This is the same as 1 over 2 to the 1, right? Or 1/2. And we're done. So f of -1 is 1/2. What about f of 3? Well, that would mean 2 to the 3rd, which is equal to 8. Okay? What about f to the 5/2? Well, that means we're going to take 2 and we're going to raise it to the 5/2 power. Now, this is where we're going to use another property of exponents, because we're going to rewrite this as what? The square root of 2 to the 5th. Okay, let's see what that gives us. Well, what's 2 to the 5th? That's going to be the square root of 32. Okay, you know what, let's rewrite this another way. Because we know 2 squared is 4, and 4 is a perfect square, so let's use something else that we learned before. Let's write this as the square root of 2 squared times 2 squared times 2, right? That's 2 to the 5th. And then we can write this as the square root of 2 squared times the square root of 2 squared times the square root of 2, right? And then this will give us 2, this will give us 2, which gives us 4, and will give us the square root of 2. And then, of course, that gives us 16 times the square root of 2. Now, you could have probably done that back here and just did 16. That's fine. There's different ways of doing this. But I wanted to show, hey, we could use some other properties. So the answer is 16 square root 2. Okay, and that's the exact answer. Now, what about D? D gives us a decimal point. So in this case, we're going to have to use our calculator. Okay, so all you have to do, and again, this is going to be 2 to the power of 4.92. And so if we just take our calculator, that's going to be easy. We just take 2 and then caret, and then 4.92 as the exponent, and hit enter, and we get approximately 30.27. And that's the answer. And so that's how we evaluate exponential functions. Getting either the exact answer, like in A, B, and C, or using a calculator when we have something like a decimal to get an approximate answer. And that's it. Have a great day.